So we're going to go back to special triangles a little bit and show how trig functions work into those special triangles and things that we should know. So with a 45, 45, 90 triangle, we should have two sides that are the same, and then we have one side that is not the same. But if we use our Pythagorean theorem, well, 1 squared plus 1 squared is equal to this side squared. Well, that would be 1 squared plus 1 squared is 2. So c squared is 2, c is equal to square root of 2. So we have 1, 1 square root of 2. All right, then with the 30, 60, 90, remember the short side was going to be half of the hypotenuse. So if the short side's 1, the hypotenuse would be 2. And then we use this Pythagorean theorem to figure out the other side. Remember, that's the square root of 3. So you could always use that to help figure out what the other side is. And so short side is always half of the hypotenuse. Now we could kind of extend that to an equilateral triangle, and that would just be two 30, 60, 90 triangles backed up right against each other. And so that could be helpful at times as well. And so when we use a 45, 45, 90 triangle, well, we've got all of those trig functions that we can use. So if I want the trig functions of a 45-degree angle, well, notice I could use either one of these. So sine is opposite. So if I'm using this one, opposite over hypotenuse, 1 over square root of 2, which simplifies to square root of 2 over 2. Okay, cosine is adjacent over hypotenuse, 1 over square root of 2, which is square root of 2 over 2. Okay, tangent, opposite over adjacent, 1 over 1, which is 1. Okay, cosecant, which is, well, if sine was opposite over hypotenuse, this is going to be hypotenuse over opposite. So hypotenuse over opposite, square root of 2 over 1 is just square root of 2. Secant will be hypotenuse over adjacent, which is square root of 2 over 1. So we get square root of 2. And cotangent is adjacent over opposite, which is 1 over 1, which is 1. So anytime I have a 45, 45, 90 triangle, and I want to know the trig functions of those 45-degree angles, well, there we go. Now, you certainly could write all of these down, but you could just make a quick drawing and remember, 45, 45, 90, 1, 1, square root of 2, and then use that to figure out what each of these trig functions are. So you shouldn't need to memorize any of these. You might just off the top of your head because of using them enough, but you should be able to just draw a quick 45, 45, 90 triangle and figure out what those trig functions are. Okay, same thing with a 30, 60, 90 triangle. Okay, we have 30-degree angle here, a 60-degree angle here. So notice the 30-degree angles I did in blue. So sine of 30 degrees. So I'm going from that angle, opposite over hypotenuse, 1/2. So opposite over hypotenuse. Okay, adjacent over hypotenuse is my cosine. Adjacent over hypotenuse, square root of 3 over 2. Tangent, opposite over adjacent, 1 over the square root of 3, which simplifies to square root of 3 over 3. Remember, multiply top and bottom by square root of 3. We get square root of 3 on the top. Square root of 3 times square root of 3 is 3. So rationalize that denominator. Cosecant, once again, hypotenuse over opposite. Hypotenuse over the opposite of 30 degrees is 1. 2 over 1, which is 2. Okay, same here. Secant is hypotenuse over adjacent. Hypotenuse over adjacent. So square root of 3 is adjacent to the 30-degree angle. So 2 over square root of 3, which simplifies to 2 square root of 3 over 3. Now, cotangent is adjacent over opposite. So adjacent over opposite, square root of 3 over 1, which is just square root of 3. So once again, you could write these down. You could memorize them. It doesn't really matter because really if you just draw a 30, 60, 90 triangle and draw those 1, 2, and square root of 3 or figure out what they are, remember the short side is always half of the hypotenuse. Okay, you can come up with those trig functions fairly quickly. All right, then 60 degree, we're going to do exact same thing. Opposite over hypotenuse, square root of 3 over 2. And then cosine was adjacent over hypotenuse. Remember, I'm using this angle. Tangent is opposite over adjacent. So opposite is square root of 3, adjacent is 1. There we go, square root of 3. Cosecant, hypotenuse over opposite. Hypotenuse over opposite, 2 over square root of 3, which simplifies to 2 square root of 3 over 3. secant is hypotenuse over adjacent, hypotenuse over adjacent, 2 over 1, which is 2. Cotangent is adjacent over opposite. Adjacent is 1, opposite is square root of 3. 1 over square root of 3, which simplifies 2 square root of 3 over 3. So just quick run through all of those special triangles. Now, these examples aren't in the book, but I am going to use the same idea to find some different sides. So you'll have a few problems that are similar, but we want to use the things that we know. Okay, so here, I used those little marks saying that those angles are the same. So if those angles are the same, then that means I have a 45, 45, 90 triangle. So I want to find the missing side or sides. So here I have 2 missing sides. Well, what can I do? Well, if I just pick one. I'm going to say if I use trig functions. So I want to say something like, well, sine of 45 degrees. And let's just say this is, I'll call it n. Okay, so sine of 45 degrees is 7 over, or n over 7. So opposite over, so whether I use this one or this one, it doesn't really matter. So say I'm using that one. Okay, so n over 7. Well, what is sine of 45 degrees if I use the simple version? Well, that'd be 1 over the square root of 2, which is square root of 2 over 2. So I know that the sine of 45 degrees is really square root of 2 over 2. Oop, not 7, 2. So use this. Solve for n. So let's just rewrite it. Square root of 2 over 2. Hey, let's get rid of that 7. We get n equal to 7 square root of 2 over 2. Now if this is 7 square root of 2 over 2, well, I know this side is the exact same. Okay, the other thing I could do is go back here. How do I go from the hypotenuse to this side? Well, I take the square root of 2 and, hey, if I divide it by square root of 2. So if I knew I had 7, and to go from the hypotenuse to this side, I have to divide by square root of 2. Well, let's rationalize that. Okay, so we get 7 square root of 2 over 2. Hey, same exact answer. So that is the length of both sides. All right, so back here. Now, if I have a 30, 60, 90 triangle, okay, I can go off of that there and think of, well, what do I need? So let's do sine of 30 degrees. So sine of 30 degrees is, I'm just going to use h. So in this case, it's going to be opposite over hypotenuse, so 3 over h. However, if I look back here, sine of 30 degrees, opposite over hypotenuse, 1/2. Oh, so that's really 1/2. So 3 over h is equal to 1/2. Well, let's write that just as a separate problem. 3 over h equals 1/2. Now whatever method I need to use, multiply by h, also multiply both sides by 2, and I will get on the left, I'll get 6h, not h, 6 is equal to h. So h is 6. Now what is this side? Okay, well, let's use, I could really use any of my functions and any of my angles at this point. Let's say I need something with this side and either the opposite or the hypotenuse. It doesn't matter. So let's pick, let's still use that 30 degree. So this time I'm going to say cosine of 30 degrees. Cosine of 30 degrees is adjacent over hypotenuse. So I don't know what that adjacent side is yet. Hypotenuse, well, we already figured out, is 6. So if I have, I guess I'm running out of room here. All right, so adjacent over 6. If I look back, cosine of 30 degrees, so adjacent over hypotenuse square root of 3 over 2. So that's just the square root of 3 over 2. All right, well, let's rewrite that. A over 6 is square root of 3 over 2. Well, if I multiply both sides by 6, that's going to get rid of both of those denominators. So we get A is equal to, well, 6 divided by 2 is 3, so 3 square root of 3. So here's my 3 square root of 3. Now, if you think back, remember, short side times square root of 3 gets us to the longer leg. So short leg times square root of 3. Now, you can use that as well, but we can use trig functions to solve those or use similar triangles.